Hello, hello. So today we have another episode of Postgres Cafe with myself, Sarah, and Gulshan. Gulshan, won't you please introduce yourself?
Of course, thank you, Sarah. Welcome, everybody. Welcome, Sarah and Esther as well. I work at Xata for the last few months, and I've been involved with Postgres for some like 12 years or something, and happy to be here and talking about things around Postgres and Postgres ecosystem.
Awesome. And yeah, I'm a Postgres enthusiast. I've over 12 years. I love talking about open source of all things. And today we're joined by Esther. Would love to know a little bit more about you.
Hi, so my name is Esther. I have been working at Xata for over a year now, and I work on the backend team, leading the effort towards the pgstream project, which I'm sure we'll talk about in a minute. I'm based in Spain, and looking forward to having a chat.
Cool. Yeah, we actually would love to learn a little bit more about pgstream today and find out more about what it is, like when would you use it? And can you tell us a little bit more about that?
Yeah. So pgstream is a change data capture tool. It's an open source project. It's made for Postgres, and the idea is that it supports replication of the schema changes. So it tracks the schema changes and it replicates them downstream. Um, it is a modular product that is supposed to be very expandable, so people can contribute to the open source project as much as possible. It has open telemetry out of the box that you can use, so it's meant to be used by everyone. It's not just the Xata project.
Esther, like I know that it is like you described very well the tool itself, but I want you to maybe emphasize one more for people like why do we need a tool to handle this in Postgres? Like why do we need pgstream? Why
Yeah.
does it come like automatically, let's say part of replication?
Yeah, so yeah, there's a lot of tools out there. Even Postgres, you have the integrated replication. Um, but the reason for pgstream was born out of the need for the replication of the schema changes, your DDL. This is something that is currently not addressed by the Postgres integrated solution, and this is one of the pain points when you're trying to replicate your data. If you have a schema on your Postgres database and you want to replicate it downstream, you have data that is coming along the stream, then suddenly your schema changes. If your replication stream doesn't capture those changes, you're likely to end up losing data or just basically require manual intervention to align your downstream store, whatever you are replicating to be able to then continue consuming all of those replication events that are coming from Postgres. That is quite painful when you have an automated service that needs to run constantly. And pgstream kind of addresses that for you by just automatically keeping track of the changes and replicating them along with the data so that any data that comes after a schema change will work for the schema change that just was applied.
I see. Yeah, exactly. So to be able to capture the changes in DDL changes, that doesn't really automatically happen. So pgstream handles this use case basically. And like when I hear about like streaming changes from some upstream to downstream, the main thing I think comes to everyone's mind and also mine, like what happens when there's like slow consumer, when there's a like I don't know lag in between and like the connection issue or something. So is there some sort of safeguarding or you know maybe more about this in pgstream?
Yeah, so that is actually one of the issues with the replication slot that comes out of Postgres is that you have to consume it sequentially in order to guarantee the ordering of the operations. So you need to consume them as they happen, and this can be a problem because you have to then rely on each individual item to be consumed one at a time. You can tell if you have a slow consumer, this might build up your replication slot lag, and you might actually end up impacting your Postgres instance by reducing the amount of free storage that you have available.
Yeah.
So in pgstream, there are a couple of ways that we handle this. One of them is we use memory guards and buffering in between your replication slot, like your listener and your consumer, so your downstream, in a way that you can keep reading from the replication slot so that you're not accruing lag, while your consumer can just pick up from that buffer. That is one of the ways in which you just need just a processor that listens to that. Then there's another way of doing it, which is if we introduce a fan out module, like it could be Kafka. That is the most sturdy solution, which allows you to just have also multiple consumers in which at that point you completely decouple your replication slot from whatever your consumers want to do. There's just the listener is just going to be processing the messages from the replication slot into a Kafka topic as quick as possible, very fast, very efficient. There's no replication slot like. You just have all the information in a Kafka topic, multiple Kafka topics that then your consumers can just consume as slow as they want without impacting your database. So those are the two main solutions that pgstream offers for this problem.
Okay. So basically, like to summarize, we have the memory guard for it. So there's like an allocated slot that's for the slot, allocated memory for the slot. And then if you pass that, we don't care. We just don't keep writing the and then there's also a layer that you can put in between. It could be Kafka or it could be something else perhaps, right? So that the other consumers can just get changes through that. I see. So it makes sense. But then, yeah, then the question comes, what happens, something happens between Postgres and Kafka and so on. So we can't like go for long for that.
Yeah, there's a lot of things that can go wrong. The system, at least on the listener side, is built to be able to work as long as you give it as long as it has memory to buffer the data. It will keep working. When you reach a point where there's nothing consuming that internal buffer that's in memory, it will stop. That configured value is by you, so you choose how much of your memory you want to allocate to that. And at that point, it will stop consuming from the replication slot. There will be metrics, there will be information to tell you that something's happening at that point. But the listener on its own cannot decide what to do in that situation because it's part of the processor or the downstream part that needs to address something's happening. There needs a restart, then something needs to happen. That will probably require manual intervention, but that is, I think, even without pgstream at that point.
Yeah, it's not the scope of the like pgstream.
Yeah, it's a pipeline that connects two things. It can only do so much when one of them is down. You have to wait until the downstream is available.
Exactly, and when the downstream is available, probably they retried it or restart it or whatever it formed, established again.
Exactly.
And it will still start consuming, correct? Yeah.
Yeah, we have a mechanism in which the downstream will be checkpointing the messages. So as it gets them, the LSN will not be advanced for that particular consumer of the replication slot until the message has been processed, which means while they are buffered and they are in that buffer, they will not be checkpointed in the Postgres until they're processed. So if your processor goes down, has to restart, and for whatever reason you restart that buffer, it will pick up back on the last LSN that was checkpointed, which means you haven't lost any data. You're just kind of going back and replaying from where you left off.
And this is a part of pgstream's check, right?
That's right. Yeah.
That's good. That's what I wanted to hear, basically. Like, how do you know? Okay, and then maybe you can also, when you said, like, when Sarah asked you, like, can you explain pgstream, you just also emphasize, like, it's modular, and maybe we can talk a little bit of the architecture of itself. Like, what did you mean by modular, and maybe a bit more information about the, pgstream architecture itself.
Yeah, so pgstream at its core, it's meant to be like puzzle pieces. That's how the whole concept kind of came up to exist. And the idea is that there are kind of two high-level abstractions within the architecture. One of them is the listener. I have been talking a lot about listener and processors. This is where it all comes from. There's the listener, which is the module that basically will be managing the reading, the receiving of those wall events. Yeah. And then there will be the processors, which are the ones that, given a wall event, do something with it. So everything in pgstream it's kind of like puzzle pieces that are either listeners or processors. Sometimes it's a wrapper around the processor, or a wrapper around a listener, but it's all based on those two primitives. And that allows us to then be able to say, connect my Postgres listener to my OpenSearch processor. It's the OpenSearch indexer that will put the data into the OpenSearch store directly. Or if I want, I can also use a Postgres listener that connects to a Kafka writer. In this case, the Kafka writer is a processor implementation And then I will have a Kafka reader, which is a listener implementation, and then my OpenSearch indexer, which is the other processor. So you just can kind of put them together, remove the ones in the middle. It's very flexible, and it means that you can also support a lot of cases by just implementing different processors. So you want to store your data in Snowflake, Databricks, you can just implement that one processor and everything else in the pipeline is already prepared for you to just plug in that last part.
Okay, so it's modular enough that people, let's say they want to write it to Parquet files or something, they can just like make a wrapper around the processor, and then there's already listener already available through pgstream, and they can just use it. So
Yeah,
that's like
that's an
puzzle
inter.
pieces, analogy. Okay, and
Yeah,
is there already anything we already have it built in? I think I know that for OpenStream, OpenSearch, and Kafka you mentioned. So, and if people wants to come up with to include their own, they already can basically.
yeah. As long as they have there's an interface. You have that interface to implement whatever you want with it, and that's it. Currently, in terms of is that what your question was, or?
Yeah, sort of like to understand, like yeah.
Yeah, it's just interface. It's at the end of the day, as long as you implement it, you can do whatever you want with it.
Okay.
Which I guess speaking of, I'd love to know a little bit more about some specific use case examples that you've like seen or like that people have talked to you about, or they're like, I would love to use this for this. Like what kinds of conversations are you having with actual users of the product?
So one of the biggest use cases that we have is the OpenSearch or Elasticsearch replication. So you have your Postgres and you want to search your data on it. It's a very common one, I think, for a lot of engineers. And that one is provided out of the box with pgstream. It's one of the processor implementations that comes with it. The other one that is currently available, as we mentioned, is the Kafka module in between, so that you can plug it in between, and that means that it decouples your listener from your processing. It also allows you to have multiple processors because of the topic being able to be consumed by multiple consumers. It means you can have just a single replication slot and have multiple processors reading from it and doing different things with it. And then we also have the webhooks is a big use case for a lot of people. You normally have a lot of people use the Postgres triggers to be able to trigger some sort of operation or some sort of behavior based on a change or based on something that happens in your table or your database. With webhooks integration with the webhooks Postgres webhook processor we have in pgstream, it allows you to then receive webhook wall events about your data changes, about your schema changes, and it will notify whichever webhook server you have subscribed about these changes. You can also select which kind of events you want to subscribe to, which tables, which schemas, and it will let you know about them. So this allows you to then have a huge range of use cases from just with this one processor implementation, because with that data, with that information, you can do a lot of things. Like if you have the use case that if I receive an insert on a table about a subscription, I want to send an email to this user, that is something that would allow you to do it. And I think there could be a million others that could just be from the single processor that already gives you all of that solutions.
Yeah, like I can imagine like notify me when like basically somebody upgrades from pre to pro, or downgraded, or like make a report every month, or I don't know, based on this billing cycle or something. So I mean, any use case that you can think of webhooks. I think that's like we talk about pgstream everywhere, like, and when I'm on the booth or talking to customers, the webhooks comes all the time. Basically, they come to like discussion all the time. So I think it's very useful use case.
Yeah, it's very helpful as well, because obviously with the triggers, you can only do so much.
Right.
By having something that is external, that can call third-party servers, that can do all of that more powerful computation, maybe that opens the door to a lot more use cases. There's one that we discussed now that the AI is so so everywhere. You could have, for example, have just your embeddings being computed on based on a webhook, right? And then update your same table, a different column, or even the same table on a later, like just as a background process that just happens based on that webhook. So like I think that the uses of the webhooks is just unlimited. You can just think of anything, and that will be a use case for it.
With good and modern and current example, I wouldn't think of like like doing embeddings through it. Like, why not?
Why not?
Yeah. And then you also mentioned like we capture changes in the wall, right? And then you can actually extract everything from this. You can listen these events and then you understand. I mean, you as a pgstream, because I associate you and pgstream so well. But then is there anything that people need to set it differently? Like let's say for wall level, because like what type of level? I mean, can it capture in every level of wall, or like it needs to have a minimal, I think, like do we need to set it to a replica identity, or I don't know, what type of level for wall? I wondered if it brings any load extra, basically. Like, do we need to record so much to be able to get these changes, or is like already available any wall level, let's say?
So just for using pgstream, you do not need to set you don't need to set the replica identity to full, which is one of the most performance invasive ones for your database.
Mhm.
Um, for example, for some of the processor implementations, there might be some data that will be missing if you don't have that additional replica identity context. This usually it's more required when you have updates or deletes that have a lot of data, for example, with toasted values, things like that, that will not be replicated otherwise, and you might miss that context. So that's where the full replica identity comes in, and that's where, depending on your processor implementation, it might end up in being some data loss, or it might be some misbehavior depending on what it's expecting. But in terms of what the pgstream pipeline does, it doesn't have any particular requirement. You need to have a replica identity, obviously, otherwise the replication will not work.
Yeah.
But other than that, it's pretty unopinionated.
Okay. It's like standard replication requirement, basically. Okay. And is there any other constraints or something to able to stream changes other than this, like, or like primary keys, I don't know, unique identity and
So you usually need a primary key if you want to. Something has to be the replica identity. So if you have only inserts, I believe it would probably work. But if you start with updates and deletes, it's gonna break and things are gonna start not working as expected. Other than that, there's no real requirement. pgstream itself kind of adds some metadata to your event so that you have some extra knowledge. Like sometimes you might want to have an ID for your event.
yeah.
It's very common if you're trying to index something in a different database. You need to know what is the ID, especially if it changes. So pgstream adds that metadata, and it relies on, for example, having a primary key. And if there's no primary key, it will look for any unique not null column. If
Okay.
there's none, it will just not set that metadata for you. It doesn't mean you cannot use it on your processor. It just means that piece of data won't be available, but you can still use the event, and maybe you don't need it for what you're doing. So it's not necessary.
Okay, I understand now. Like it's up to you. Basically, if you want to get more information, there's already a metadata that you can be used. Yeah, it can be
Yeah,
used. Yes.
exactly. Yeah, we also provide that part of the metadata is also a version. It's also very useful to have. It's a kind of two things that come together, an ID and a version, so that you can the ordering of things is preserved downstream, especially when you're adding buffering in between, Kafka, things like that. You want to still keep that consistency on what you're reading. So we add that person, and that person it's nothing other than the LSN value. So it's literally as it is. I mean, we're just keeping it there for tracking purposes more than anything, and
Yeah.
it's very handy. So
As a human, I appreciate it. Cool.
So as a real world example, how are you guys actually using pgstream at Xata today? What does that look
um,
like?
so we are using it for replicating the data to OpenSearch. We have in Stata we have the ability to search on top of your Postgres data. So this search feature comes from our replication from Postgres data to OpenSearch. That's how we basically get you that feature to work. And in addition to that, we also have a custom processor implementation, which is dealing with our files. So when a user deletes the file from their table, there's kind of a watcher that's looking for those file columns to be deleted and be then triggering a delete on our S3 store, so that you don't keep the files longer than they're supposed to be there. So we do have a couple. We actually have the one of the use cases that's already implemented with pgstream, and also a custom implementation, which was extremely easy to implement. So, where it should be easy to do for any other use case. As simple as that. It's just you don't need anything else.
That's actually cool. Like offering search on top of Postgres and on another platform, basically open search. And I mean, not like an advertisement, but it's easy, basically possible with the technology, and everybody can do it themselves because as all the tools that we mentioned here in the series, pgstream is also open source and anybody can use it. And we would like to hear your stories. If you are using it, let us know.
Absolutely. I mean, it's a fairly common use case needing to combine Postgres and search together. So like the fact that this makes it really streamlined to do that is cool. I like that as a tool.
Okay. Do we have any other questions, Sarah, for today?
I think that's it. I
Okay.
think besides how would users get started? I'm assuming this is hosted on GitHub.
Yes.
Yeah. There's a GitHub repo, and there's like a big README with documentation on how to use it, all of the configuration. I mean, it's a CLI tool, but it also can be used as a library. So we will be also documenting how to use as a library very soon. So I think it's gonna be it should be very flexible for anyone to use it. And if there's any questions, always open an issue, reach out to us.
Thank you.
Awesome. Makes it easy.
Yep. And I think that's it, folks. Should we wrap it up? Thank you for watching, and thank you, Esther and Sarah. And
Thank you.
until next time.
Thank you.
Bye.